Hi, today we'll be talking about Google Sheets name functions. In August of 2022, Google announced 9 new functions and a new feature to create custom functions that can use built-in Sheets formulas. This is not the same as writing custom functions using Google's AppScript. I suggest if you're interested in learning about these 9 new functions to visit Ben Collins' site and take the free course I did. I will be including all the links in the description box below, and this will also include a link to the name function library I have started, and you will be able to make a copy for yourself and add your own name functions as well. Name functions let you save and name your own custom formulas. These are built with regular Sheets functions. One of the main benefits is being able to simplify the usage of complex functions. The name functions can be used in other Google Sheet files as well. Also, changing the name function definition updates wherever they are used in your sheet. This is not the same as if you had a very complex formula and needed to change it. You'd have to manually hunt them all down one by one. Today we'll start with a very simple example and then gradually build on it, making it more generic and useful, albeit more complex. As we build this example, I will share many tips, and we'll also discuss suggestions to improve name functions for Google to consider in future releases. Alrighty, so let's go ahead and get started and dive right in. And I'll start with just a blank sheet here, a little scratch that I have some emails or potential email addresses here anyway. And let's say that we wanted to extract the ID part of the email address, so the part up until the @ sign. So whenever you write a name function, it's recommended to write the function itself and then move it into the name function editor. So my approach has always been kind of a onion approach. So I start simple and then combine later as I get the various components working and debugged. So the first thing I'm going to do is I want to find where that @ sign is at. So there's a function for that called find, and we're searching for the @ sign. So we'll just put in the @ and then the text of search is going to be A5. And we can just fill that right down. Those are because there's no @ sign. We can always fix those later with a if error function. All right, now we need to find the string to the left of the @ sign. So we have a function for that called left. And the string is going to be A5. And the number of characters is going to be the value we calculated here, -1. We don't want to include the @ sign, and we'll just copy that right down. All right, now once we get that, we could combine those two into one. Both seem to be working, so why need a helper column? That's the way I look at column B as kind of a helper column if you can do away with it. So we'll just paste that up here and then grab the also the code here from the function with the find, and we're going to get the left, and for number of characters we're going to put in what we had before without that equals, and I think that should do it. Yep, looks good. And we'll copy all the way down. Okay, not too bad. All right, let's put this formula as text right next to the cell. And I can just start with a single quote, and then I'll just paste that in, and then it'll become text versus a formula. Just so I have a reference point as we build the name function. Alrighty, so now to make the name function, we go into the data menu and then choose name functions. And the first time you go in, you'll see this screen. Well, the first time there's a name function in that sheet, you'll see this and the example and name like my function, but we're going to give it a better name than that. So we'll go ahead and say add new function. And we're going to call this one extract email ID. This is optional, although highly recommended, so that it shows on the screen and it'll give the user an idea of what this function actually does. So in this case, we'll say returns email ID portion of an email address. We always edit later if we want to. Now, placeholders. Placeholders, those are like for the parameters that you'll be sending, the arguments, parameters, it's used interchangeably. It says it's optional. I don't really see them as optional. If you don't, it's going to want to make one for you. So I always say just put it in. And you can pretty much name your placeholders whatever you want, but I would avoid anything that might be like a function name, like cell, C-E-L-L is a function name. And you can use that, but if you're not careful, it could attempt to put the cell function in your name function. So I like to avoid them. And you could change them later, not so easily. We'll talk about that at the end, but I've done it. It's not the worst thing in the world, but let's just call this, let's just say ARG for argument. And then we put in the definition, and we could paste what we had. You got to press enter, so you type in, and you have multiple placeholders. We're only going to use one. I forgot to press enter and it was complaining. Now we'll put in the definition. Now that's just pasted right from here. And now what we want to do is replace the cell reference from A5 to ARG and the other one over here. Notice when I do that, it changes the color. So let's say I typed argument. It doesn't change colors. That's a hint that you should be looking for to say, oh, I typed something wrong, either up here as my define my arguments or in the formula. So they should be that other color. And then we hit next. And then we can put a description for the argument or arguments. It's optional. Highly recommend that you do. So this will be call it cell, I don't know, we could say, keep it generic, the email address to perform and then again another optional description for the argument. I think an example, I'm saying that we just did the description, so this will show as well as an argument example. You can put anything you want. You could write, you could put in, you know, Jane Doe, sorry about that, Jane Doe at example.com. We could put in A5, whatever you want, doesn't make a difference. And we'll say create. All right, good. We just wrote a first name function. So now let's try to use it. So right here in the cell, we can start any formula with the equal sign, and we can start typing EX, and then once we get there, there's ours, and it's showing as a name function. So we can click on that, and once an argument, we point to cell A5 in parentheses, and we can also have it autofill. Wow, look at that. So let's just write, let's put this formula to the right as well as text. So which do you like better? Typing this or this? Which is more intuitive? Which has been debugged? Well, we're not totally done with this because I see a bug here and here, but we saw that earlier when we were just doing it the old-fashioned way. But let's fix that now. So we'll go back into here and choose edit this time. And we can fix any of those errors like that by changing the definition and surrounding it with if error. And then another parenthesis at the end. And they go away. Okay. Now, the if error function takes an optional second parameter, which we didn't feed it. But for completeness, let's put it in now. So let's say you want an empty string. So we'll just put that in there. So this goes back to what I was saying earlier in the opening, that if you want to update your formula, it applies anywhere that's used without having to change anything here. Whereas if we said, oh, you got this dozen places in your spreadsheet, oh, I forgot about if the character wasn't found or some error, then you have to go hunt them all down and go put in the if error. Alrighty, not so bad, kind of useful function. Well, let's keep going and building on that. So now I might say to myself that, you know, maybe we can make this more generic. Why limit it to just working with email IDs? What if we wanted to grab anything to the left of some character? So let's get some more data. I'll just copy over some data I have laying around. And we have a couple email addresses, but we also have some strings as well, just generic strings. So if we wanted to write this out as a regular function first, we could do that. So the function is going to be using the left. It's pretty much the same function, except that in this case the character is going to be passed as an argument. So instead of hard coding it in there, so in this case it's really kind of hard because we already got the function working, and that @sign's been hard coded in the formula. So the only difference this function is going to do for us at this point then is take another argument, say, okay, what character do you want to use to make it more generic? So this is going to be a totally different, it's not going to just work on emails, it's going to work on any string. So that name doesn't make sense, but I'm going to leave this one alone. And we're just going to make a new one by making a copy of that one. And it always starts by adding the word copy and an underscore. You can leave it that way if you like. But I'm going to change the name totally to string left of character. String to the left of the character. And this will now become returns the left part of a string based on a specified character. All right, so we already got argument. So we need to create another one. Maybe we don't like argument anymore. Maybe we want to rename that one. Well, there is no rename, but the way to rename, you'd have to delete it and make a new one and then fix your definition. Hopefully there will be an option for renaming in the future. That's one of the things I'll bring up again at the end with all the other things I thought about as I worked on these. So this is going to be, let's say, the character. So we'll just say car. We could leave as argument 1, but I'm going to get rid of it. And I'm going to now call this one string. Now it makes more sense. So we're searching for a character in a string. All right, so we come to our definition. And this time now notice ARG is not a different color, so we're going to have to change that to string. And for the @sign, we take that out. And instead of that, we put in char, C-H-R. And there was another one here. Where was it? Arg. A-R-G becomes string. And I think we got it. If not, we'll fix it. And now we have the details for our arguments. So one for character will be the character to search for, and this could be a cell, so we could put A3 if we want, or we could put in something maybe in quotes just to show it's a string when they see the formula, and put in, I don't know, we'll put in outside that. Argument description for string, this is going to be the string to search, and this is going to be an example, easily, well, let's write A1 and create. Now we have 2, and now over here we'll come back and try this out. So we could say equals and then str, and there's our name function. And I didn't show it to you before, but we could just, I just clicked on it, but once you press the tab key, and then you'll see what we've been going through over there. It tells you a little bit about, it even shows you the formula and definition right there, which is kind of cool. And then it shows the arguments, fortunately off my screen, but we got at least the car. So now the car in this case is going to be the @ sign, and then the string is going to be A14. And we're not going to autofill. And here we go. All right, so now we just made it more generic because it doesn't just operate on looking for emails. So let's just copy this down here, and let's say we wanted to use the comma. So this shows us the part of this name up to the comma. And maybe I'll just stick one of these over here, maybe 2, just so you can visualize. It's coming along nicely. All right, I don't know what I'll put in for this one. Let's copy this one straight down just to show that I'm searching here for an @ sign, and it returned a blank because there was no @ sign. So whenever I create name functions, I usually have a sheet and a whole bunch of examples, and I want to try to break it, quite honestly. So put in expected arguments, leave out, see what your function does, go back and fix it, unless you choose to make, well, sorry, you didn't do it what it's supposed to be entered, and let the user deal with it. That's up to you. That's all up to you. All right, so this one would also be the @ sign. We'll just copy those 3 down, those 4. Well, let's go all the way down. Let's show bad email has no @ sign. Alrighty, we're making some progress. All right, so that looks like it's working, debugged. What might someone be thinking now? Like, okay, we got this function here called string left of character. The first thing that crossed my mind was, hey, let me make another one, string to the right of a character. But then I said to myself, wait a second, how many functions do we need here anyway? Or can we take the existing one and extend it and have it serve multiple purposes for us? So let's go ahead and copy this data down. Let's go one more cell, leave us a little break. And we're going to take what we started with, make a copy of that, and work on a more advanced name function that works for the string to the left of the character or to the right of the character. Now this one the left side we already got nailed. We got the formula for that. The right side, depending on how you want to handle it, could get a bit more complicated. So I'm going to start off by writing that part here, and then we could combine that with our existing name function later. So we still need the location of the of the string, of the character you're searching for. So we can grab what we did up above and come down, and we'll build on it. We'll make it slow a little bit at a time. And then there's a function called mid string. Now, if you start typing MID, it finds the middle segment of a string. My first thought was, well, geez, I used the left for the left, and there's a function in Google Sheets called right, then logic would say you would use the right one. And maybe you can, I'm sure you can if you wanted to, but I chose to use the mid string. And the other thing that you should know, if you've worked in Google Sheets or just about anything for any given amount of time, there's usually more than one way to solve the same problem. Some may be more efficient than others, but if they both work, then fine. So I'm going to use the mid. Mid is, say, you want to find a mid segment of a string, and the string, and then where you start at, and then the length. The length is where it gets a little interesting and can get a little more complicated. But let's just start with this. So the string is going to be A24, and then starting at, we want to find the character after the @ sign in this case. So we'll use find, and then we're just hard coding now. We're not into the name function with arguments yet. And we'll find that in A24 and +1. And then for the number extract length. So this is up to you. You could cheat or you can be honest. What do I mean by cheat? Well, how long do we need? Well, we have to calculate that. But if we put in a much larger number, it's going to take it to the end anyway. That's the cheating part. So I could write 1,000, and that should work. Okay, and sure enough, it does. Now, let's get back to that function and read up on it. And if we click on the Learn More, you'll see what it says for the extract length. The length of the segment to extract. If the end of the string is reached before the extract length characters are counted, mid returns the characters from the starting @ to the end of the string. Well, yeah, okay. So as long as your string is less than 1,000, you can write 5,000 for that matter. You're okay. So that's kind of the cheating way. But look at the notes here. To return the contents of the string starting @ to the end of the string, use the len to calculate the length of the string that would be returned rather than simply specifying a large number. For extract length, oh well. Well, I'm going to leave that up to you, but we're gonna do it the recommended way, which just means a little bit more work. Oops, so sorry for that. This Windows 11 is driving me bonkers. Every time I move over there, it pops that up on me. Righty, so in this case, let's say we want to separate this into its own cell, and we'll work on it, and then onion approach, we'll combine all these together. So we need the length of the string, the total length of the string, minus where we found the character that we're searching for. So there's a couple of ways you can do this. If you really wanted to, let's say we add a row here, and let's change this font to a non to a monospace font like I think it's called Courier. Yeah. All right, and then below this we could put in a little count grid. Alrighty, that should be fine. So that tells me right now, oh, I start at 0, right? So I'm thinking arrays. We'll start at 1. Sorry, I'm moving on. So there's, we know it was 11, so there's 10, there's 11, and there's the @ Why do I change it to a fixed font? Because if it wasn't fixed, the numbers and the letters wouldn't necessarily line up. All right, so that could be helpful for us. If we take the length of the string, it looks like it should be a total of 22. Let's see, equals len 22. All right, and then we already know that that's where the character is. So if we took that minus that number, it gives us 11 as well. So that would mean that we need to go 11 characters. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's your formula. All right, so now let's roll it together. So, well, at least the right side together. So it'll be equals mid, and there's your string. And starting at the location of the character +1 that we're searching for, so we'll use the find, and this was the @ and then text to search is back to A24, and we'll skip the third parameter, and we want to go +1, and then for the next parameter for mid, the extract length. So that's going to be what we did before in the other cell. So that's going to be, by the way, sometimes just for clarity, I put spaces, it's not required, after the parameter commas, just to be able to read it, but some people do, some people don't. I'm going to put it there. And then in this case, we wanted to do the len of A24 minus where the string is. A lot of repetition of parts of the formulas here. I think you got it. I think I need one more parenthesis. Yep. And enter. Hey, it worked. All right, so that's the right side formula. A little bit more involved than the left side. If you want to play cheat, you can get this whole section right out and just plop in a big number. But we're gonna play by the rules. Well, at least for this class. All right, so now what we want to do is I want to make these back the way they were. And, well, actually we don't need this row, so let's delete that row. I don't know if you guys ever used this format painter before, really handy tool. Click on the cells that you want, format painter, click on the next range, and it copies the format for you. I just learned that not too long ago. It's been staring at me all the time. Excel had it as well, and I never really knew or used it. There's so many parts that most of us don't know about until somebody brings it to our attention, or we just discover it by accident. And then you wonder how we ever managed to get along without them. Alrighty, so let's put this all together. So let's see, I'm going to want that handy. So let's put that over there as a string. And I think yeah, we put it all together there. So at this point now, we could make a copy of this, and we're now going to call this return string based on character. So now we're going to say here for the description, returns the left or right part of a string based on a specified character. Okay. And we need another placeholder because we now need to know are we going left or right. So let's call this direction. Press enter. Now we have 3 parameters. And we have this formula over here. So editing longer formulas in this box, I will tell you, can be challenging. There have been many times where I've gotten here with what I would consider some fairly longer ones, and parentheses always challenging, and kept getting parse errors and stare at it and it's hard to find. So something like this might be best writing here and then dropping in. So let's grab what we got already, and we'll just pick any cell and we'll just paste that in here. But the problem is it's not going to work. Why? Because we have placeholders here, not references to cells. So you got string and car. If I press enter, it's going to not do anything. So because of the if error. Let's take if error out so we can get in there and you'll see what I'm saying. Okay, it doesn't know range name string. So here's the tip. I don't know if any of you guys use range names. I use range names all the time. So they make your formulas much more readable and also makes them more maintainable. So a lot of times you have to worry about relative and absolute referencing. And when you use a name range, if you want to move something, it could be to a different sheet altogether. All you got to do is update the range name. So let's do a couple of quick range names. Well, let me show you an example first. And maybe if you're an accountant out there, don't shoot me, but let's say we had sales, and we had cost of goods sold, and then we'll write profit. I don't know if that's net profit or whatever. Again, I'm not an accountant. But then we had a number 50,000. Cost of goods sold, let's say 30,000. And the profit is going to be 50 minus that. Okay. Let's make things line up a little bit just so it doesn't look weird. Let's make them bold. All right, so you look at the formula and you say, okay, you know, it's a very simple formula, but if it was referencing cells off your screen, sometimes it's very hard to, all right, now you got to go track down cell B55. Oh, that's what they're talking about. So let's do some quick name range. There's a little side here, but I think it's worth it if you haven't done it. If you haven't done it, you could just fast forward to the next section. But we'll just name a range. We go to data, name ranges, and we'll add a range. We'll call it sales, and done. And then we'll name another one, and we'll call this COGS, cost of goods sold, and done. And now our formula, instead of A34 minus B34, we could write sales minus COGS. And you get the same result. And now when you read the formula, you don't even care where the cells are. You see what I mean by it makes it much more readable. All right, so we can use that to our advantage when we would make it easier to go back and forth from the real formula and the name range by using name ranges. So let's say we have another cell here. Let's call it, let's give it a label. And we'll call it search character. And we'll put in the @ here. I just drop that in? No. I have to put a single quote, otherwise it wants to make it something else. Go away. And we're going to call this, we're going to call this, what does our formula call it again? That's what I wrote. String and car. Okay, so this is going to be called car. And I'm going to pick any cell and just call that string. All right, close that box. So now why is it still giving me an error? Left string. I should pick it up. Let me try just retyping. I don't know if it doesn't like it because I named it string. Because obviously it picks it up on that. All right, so that is not working out for me. So I'm doing something wrong here. Let's go back to name ranges and go to this one, and we're going to call it str. And I think car should be okay. And then we'll change this to str. See if it didn't like the word string. Here we go. Okay, so lesson learned. But it does work. And now we don't have A29 in there, and the hard coding the @, and we could easily now drop this into our definition box when we're ready. But right now we got to take this and then roll what we did over here into that as well. So basically we want to say if the direction is to the left, or you can say not to the left, it doesn't make a difference, then do this, otherwise do that. And there's a function called if. So let's go ahead and edit this function. And we can write if, before we do that, we need a direction named range. I'll just write it over here. And let's say L. We'll make that one, and then go back to data, name ranges, and we'll add a range and call it direction to match our argument. Okay. All right, so let's go ahead and start building this. Again, if, and now we can write direction equals left, do this. Otherwise, do that. But let's just see if we got this part working first, and then we'll add the do that side. So for now, I'm just going to put in double quotes. And we get mini because it's left. And now let's go ahead and build the right side of this function, which we did over here. So we could just grab that and fill in some of the blanks. So this whole thing now replaces the double quotes. And we got to remove the references to the cells. We don't have to, but we want to. So we can paste this into our definition box later. String and find We call this car, I think it was. Should be in the left side, right? Yeah, car, and then str, car, str. I think I got them all. If not, we'll find out soon enough. Enter, and there it works. Now let's just test it out. Let's say we want the right side. So actually, if you look at the form, it says if it's equal to left, do this. If it's anything else, it's going to do on the right hand side. But for argument's sake, no pun intended, let's put it on. And we get the right side. Wow, cool. Alrighty, so now we're cooking like with gas. Let's copy this up and do some testing. And let's make this one left. And let's copy this down. And, oh, okay. Let's get rid of this. We don't need that anymore. What I do wrong here. These all stop me because this is, I'm thinking like it's a name function already, so it's not. We got to get it into the name function. Otherwise, it's going to, since we're referencing the same cells, you're not going to get any different values, right? All right, so now we have all that. Let's copy this into our named function definition. So we took a little detour there, but imagine trying to enter that in there and test and debug what we just did in this little box. Good luck. So now we could drop it right in, and we don't have to even replace any of the placeholders. They should all be there. Direction, character, string. str is not lit up because we changed the name because of the name range. So let's go ahead and make it match. If in case we need to do any more debugging, it doesn't take that much. So we'll create a new one, we delete the old one, create a new one called str, and now they're all lit properly. Next, and direction, enter L to extract to the left of the specified character. Anything else will extract to the right of the specified character. And direction example could be L. It could be a cell, of course, A1, whatever, if you want to do that. String, that's the string to perform it on. We lost the definition. There's no rename of arguments, unfortunately. So we have to delete and recreate. Hopefully they'll allow us to rename in the future. They allow you to rename the function. Why can't they allow us to rename arguments? Anyway, the string to perform the extract on. And we're just going to put in a cell reference here and create. All right, so now let's save this puppy. As a label. And we don't need any of those anymore. And instead of using that, we can now do the function equals string, return string based on character. The character in this case is going to be the @ sign, and direction, let's go left, and string is going to be A24. And there it goes. All right, let's copy this down to here, and this time we're going to use, oh, I forgot, we took out the if error, right? So this has thrown us an error. So we come back to our lovely function and choose edit. And this we can do right here. I'm comfortable just surrounding something with an if error in that little bitty box. If error, and then at the very end, close parenthesis, comma. If you want to specify what happens if there's an error, I'm just going to write empty string, close parenthesis. Oh, enter, I click next, and update. Oh, error went away. Okay, but I actually want to use the comma. And we get Jones. This one will just show what happens when there's no @ sign, so we could copy that down. And let's just put that as a text as well next to it. So you have a reference. Let's copy this down here, and let's say we want to get to the right. And we'll just, again, anything that's not L, then that should work. So if I put R, it's not L, so it gives me to the right. But notice the space in front of it. This is a decision you have to make when you make your name functions. Freudian slip there, because I was thinking of our good old friend Bob Ross when he makes his painting. There was like a happy little tree here, whatever. It's your painting, you make it. It's your function. You do with it as you choose to do. So you can build that into the name function, or you can handle it outside. So let's just, I'm going to say I'm going to handle this outside. Leave certain things up to the user. So we'll just surround that with the trim function. That take care of the beginning of the space. All right, but so that parameter direction, if it's not L, if it's anything else, it's going to return to right. So theoretically, I can put that. But what if I put this, lowercase l? Well, lowercase l is not the same as uppercase l. So let's go back to our name function and fix that. This I also feel comfortable fixing here instead of in the sheet. But if you don't, then you want to keep that function available to you until you're totally satisfied you're done. So you make it life easier as well. So what we want to do is convert whatever we pass it as direction to uppercase. So what we have to do is put the upper around the argument direction. And that should handle it. That's why I said I'm comfortable doing that in that little window. So now we have lowercase l, and it still gives us left, and this was uppercase L, and it still gave us the left part. Let's copy it down one more time. And copy this down and make it right. Okay. Alrighty, so now I think we are done. I think we've taken that function from a really basic part where it was very specific to extracting email IDs, made that easy to do, and then we expanded it to say, you know what, why limit it to just email IDs? Why not just get the left of any string based on a character? And we got that working. And then we said, wait a second, now we need a right side. Oh no, why can't we just enhance what we already did and make it do either one or the other? And again, that's up to you. You might say, you know what, I'd rather have two different functions. String to the left of a character, string to the right of a character. That's your decision. You get to make your own name functions. There's no name function police, so you get to do whatever you want. I chose to make it one function instead of two, with adding another argument. But that's pretty much up to you. You get to decide that yourself. All right, so at this point, just a couple other things I want to show you, and then we'll be wrapping up soon. So you can nest name functions as well. So let's make a new name function, and we'll call it double. And you know what? I don't even care. And this will be arg. I don't care about the description, and we'll just say equals arg times 2. And I'm not going to worry about anything else, and we can just say equals, well, let's put a value here, we call 5, and we can say equals double that, and we should get 10. Okay, all right, let's make another one and call it triple. And this definition is gonna, oh, we need arg, and this will be equals arg times 3. And go ahead and create that. And now, just to show you, if we doubled and then tripled, we should get 30, right? So we can say equal triple, double, extra parenthesis, you get 30. So now you have two name functions nested within them. So that's good to know. You may have some complicated name functions and then very specific in purpose, and then just combine them in as you need them in Google Sheets directly. We already showed you how you can copy. There's other options there. Of course, you can remove one. And this doesn't say rename here, but when you click on it to edit, if we change the word here, double to say DBL, and then saved, if we check our formula now, it changes it DBL from double. So that's the rename process. Go into edit and just change the name. Other than that, there's an option, I didn't want to get into edit, so we'll cancel. There's an option import. So if you have name functions in one sheet, you can import them into any other sheets as well. So you just click on the import, and then from here, you find your file. If I click on my recents, I might see something I can grab one from. Click on the sheet, and then it will give you a list of name functions in there, and you would just click on the ones you want and choose import, or you can say import all. If you do import one that has the same definition in the current sheet, it replaces it. So we'll won't want to do that right now. So we're just going to close. Just want to make sure you knew about that feature. Let's see. All right, so I guess the next thing is to leave you with that library that I hinted at earlier. And I'll probably just highlight one of the functions that I spent the most time on and I saved for the end, but it was the most difficult one I worked on. And that is, let me get to the main page. So this sheet has 21 name functions in it, and there's a name of it. I added a category and a description. You can make a copy of this for yourself and use them as is. You can extend as well. As with my other example, each function has its own tab, because I always do as extensive testing as possible. I want to make sure it's working for even cases it's not expected to work. And then, so if there's 21 functions, there's 21 tabs, each one matching the function itself. That could be helpful for you to learn how to use it, understand it. So, and there's also a free giveaway. I put in a little Google Apps script so that, because there's 21 tabs, getting to those tabs could be a little challenging. You could click on the tab thing there and maybe locate that way as well, and jump there. But from the home library page, I call it library, I put a little button here, say go to. So if you wanted to get to, let's say the one we just worked on, which is extract strings between character, no, return string based on character. Anywhere in that row, click the go to button and it'll bring you right to that tab. All right, so take your time, make a copy, choose if you like this. If you don't like it, change them. If you want to add them, add, delete them, it'll be yours, it's your copy, you do whatever you want with it. I do want to just show you one that is a bit advanced, and it took me the most time to work on, and it was definitely one of those headbangers where I had to walk away and come back with a clear head, because there was a while there I felt like I was not getting anywhere. I was actually going backwards. But the one that I'm talking about is string contains multiple. It returns logical true or false if the specified string contains multiple search keys. Excuse me. So let's go ahead and jump to that by using the little go-to button. And you'll see some examples. These are some strings to match: good, wonderful, fantastic. I left the sheet in here called the same name except dash WIP, work in progress. You can kind of, if you looked at that, kind of see what I went through as I developed this and then cleaned it up and put it in this sheet. But a lot of these functions use regex, regex batch, regex extract. Regex is really powerful. If you've never worked with it, it might be something you want to look into. I'm sure there's lots of videos on regex and Google Sheets. I also did, maybe I'll do a presentation for that as well, but I did one for my company at one point as well. I learned a lot, but they are difficult as far as the expression. It's basically expressions that you pass, and it gives you all kinds of things in really easy manner. But this is based off of regex match, and it uses these pipe characters as the OR. So it's saying if A2 contains good, wonderful, or fantastic, to return true. And you can see in this case it's false, and this is true, and that's true. So regex is confusing, so I decided to make this into a name function as well. And then I took it to I think another level. So in this case, you'll see the strings that I want to match. I put in a cell instead of burying them into the formula, or cells into a range: good, wonderful, fantastic. And then the name definition is here, right here, so you can see. It gets a little hairy in regex, this parenthesis, question mark, little I, right parenthesis, that means ignore case. So that is something that we didn't put into this regex up here, that if this was uppercase good, it should say false, because it's a literal exact match. We'll put it back the way it was. But that should take care of that, and that would be your decision. Should it be exact, or should case not matter? That's your decision. Then it uses this join function, which is not super advanced but very handy. But it joins a range with a specified character. In this case, the pipe, because we want to have those words surrounded with the pipe, and we surround the whole thing with if error, and then in this case, now we can use the name function. String contains multiple, the cell A13, and then the range of strings that we want it to consider. So that was pretty cool. Then I decided, hey, you know what? Let's push the envelope a little bit more. So what if you wanted to have the strings to match, but all the possible strings to match, and then based on checkboxes, have it it automatically determine true or false. So that's what this is all about. And here's all my little tests going on as I'm developing this. So I kind of left them there in the work in progress. You won't see them in the clean version. So let's look over here just so you can focus on what's changing here. So you are good is true, and notice good case is upper or lower. It's every way. But we have it checked. If I uncheck it, oh, look at that. It's gone. Let's say wonderful. And different case for wonderful, and we still got wonderful true there. Takeaway fantastic. So that's pretty cool. I think so anyway. Maybe you want the checkboxes on the left side. Oh, we can do that. So you might think of some applications for this. Make sure you check the references that I've listed in the notes. There's a site I found, InfoSpired, as well. They got some really good examples. One of which I borrowed in our library, but I did change it a little bit, but not too much. I think that was this running total sum by group. Was pretty cool. So kind of nice. This one, as you can see, it's a running total every time the group changes from P100 to A51. So it's 100, 200, 300, then it starts running total again. Pretty amazing, if you ask me. And this one is by month. So it January was 6, and 4 is 10, and February, etc. This one's by year. That's really cool. So feel free to, when you find something, you can bring it into your library and make it your own. Maybe use as is, or maybe modify it to your own needs. I think it was in the same link in InfoSpired where I saw one, if you've ever used the query function, a really powerful function. Use it almost all the time. And a way to use name functions with query, similar to the way I was showing you with the checkbox for searching for a string, to change the query based on what the user selects. So that's a really cool example. You might want to spend some time looking at that. Anyway, I think I'm pretty much done for what I wanted to cover today, and I want to thank you for taking the time with me to learn about name functions. If you have any comments, of course, just leave them in the comment box. I hope you learned something today, and I look forward to doing more of these in the future for you as well.